everyone. I am Dr. Kiranmayi, Area Chair and Assistant Professor, Digital Transformation and Operations, Department of Management Studies, School of Business, Aditya University. In this present lecture, I am going to discuss the problem of on normal distribution, how to calculate the normal probability, how we can make use of normal probability in decision making and to interpret the given data. So, here is a case where we are given the data pertain to marks of the students. So, the marks of the students we are given that follows normal distribution, and we are also given mean of the scores is as 45, standard deviation of the scores as 10, and we are also given that total 1000 students have attended the examination. So, this is the data we are given, and we are asked to find out number of students, number 1, scoring less than 40 marks. So, in order to find out, we are not asked to find out the chance of getting less than 40 marks, we are asked to find out number of students scoring less than 40. So, for that, first we have to find out what is the chance of scoring less than 40 marks. Therefore, we have to find out the probability, that is x less than 40, and we have the formula to calculate the normal probability, that is z is equal to x minus mu by sigma. So, this is the normal probability formula to calculate. Okay. Therefore, x, here x we consider as 40. So, 40 minus we are given mean value, that is z is equal to x minus mu by sigma. Mean we are given 45 and standard deviation is 10, and this is minus 5 by 10, that is minus 0.5. Therefore, z, it is the z score, z value, z less than minus 0.5. Alternatively, it can also be written as z greater than 0.5. If we consider the normal probability curve, this side it is minus infinity and it is plus infinity, and the area this side is 0.5, it is 0.5. Since we know that the normal probability curve is a symmetrical curve, therefore, it is the entire curve is divided into two equal parts. So, 0.5 lies somewhere here, since it is positive value, therefore lies on the right side, and we are asked to, we have to find out the probability area greater than 0.5. So, all the data points greater than 0.5 lies this side. So, the shaded region denotes the area greater than 0.5. And now, to find out this area, we know that the total area of the right side is 0.5, and this from this total area, if we can subtract the area from 0 to 0.5. So, if we subtract the area from 0 to 0.5, from 0.5, we are going to get the area of this shaded region. And now the question is, what is the value? What is the value of this area from 0 to 0.5? And that we can obtain using this values of this normal probability table. So, we have to find the area between 0 to 0.5, right? So, 0.5 is this one, okay, and 0.5 next value is 0. So, therefore, under 0 we have to calculate. Suppose if it is 0.51, then we have to go with 0.5 under 1. Okay, this is how we have to. But here in this problem, we have only 0.5, therefore, next value is 0. Therefore, 0.5 under 0, the value is 0.1915. Therefore, the area from 0 to 0.5 is 0.1915, which we have got it from the table values. Now, we have to subtract this value from 0.5 minus 0.1915, and it is 0.3085. 0.308. So, which is approximately 31%. So, it means that 31% chances are there to score less than 40. But we are not asked to find out the probability, but we have to find out how many students out of 1000, how many students have a score less than 40. So, this is the probability. 31% chances are there that the students to score less than 40. Okay, now multiply this 0.38 with 1000 to obtain the count of the students, okay, into 1000. That is 308. Let me 308.5. 308.5. Since count persons we cannot represent in decimals, therefore approximately it is equal to 309. So, now coming to the interpretation part. So, what is this 309 tells us? That is more important. So, from this value we can conclude that, we can interpret that, yes, so out of 1000 students, 309 students have scored less than 40. So, this is how we can make use of normal distribution to identify, to predict or to model the values, okay. And likewise, coming to the second case, we are asked to find out how many students have scored more than 60. For this also we have to find out P of x greater than 60, that is x is 60, mean is 45, and what is this standard deviation is 10, and 60 minus 45, that is 15 by 10, that is 1.5. So, P of x greater than 60 is equal to, it is z value, since P of z greater than 1.5. Okay. So, let us consider the probability curve again, minus infinity, 0, plus infinity, it is x-axis. Okay. So, we have 1.5 lies somewhere here. So, which is greater than 1.5. So, all the points greater than 1.5 lies this side. So, the shaded region denotes the data points greater than 1.5. Okay. So, again to find out area of this region, so we have to subtract this the area between 0 to 1.5 from 0.5 again. So, how we can find? Go to the normal table values. Now, we have to calculate, we have to find out the table value 1.5, that is 1.5, right, the area between 0 and 1.5. So, 1.5 means 1.50. So, where it is 1.5, this, and next 0, 1.50. So, this is the value 4332. Okay. Now, substitute here 0.4332. So, subtract from 0.5 minus 0.433. It is 0.0668. 0.066. It means that 6.6%, that is approximately 7% of the students have scored less than 7%, chances are there that the students to score more than 60 marks. Okay, but now we are asked to find out number of students who scored more than 60. So, multiply this with 1000 into 1000, it is 66.8. 1000 into this 0.0668 is how much it is? it is 66.8, that is approximately 67. It means that there out of 1000 students, 67 students have scored more than 60 marks. Okay. And coming to the next one, the last value, that is we have to find the how many students scored between 40 to 60. How many students scored between 40 and 60 marks. Okay. So, for this model, first we have to find out Z value for 40. That is 40 minus 45 by 10. It is minus 5 by 10, that is minus 0.5. Okay. Next, for 60 also we have to find 60 minus 45 by 10, that is we have got this value as 1.5. Okay. Now, for between case, let us see how to calculate. Okay. Right. So, first we have to consider this minus 0.5. So, minus 0.5 lies here. This is 0.5. And next 1.5. 1.5 lies somewhere here. We have to find out this area. This area. So, how we can find out this area? Sum up the area from minus 0.5 to 0 and 0 to 1.5. If you sum up these two areas, you are going to obtain the area of the shaded region. That is P of minus 0.5 less than Z less than minus 1.5. So, for the area from minus 0.5 to 0, we have already obtained, that is 0.1915 plus the area between 0 to 1.5, we have obtained it as 0.4332. Let us sum up this value. 0.1915 plus 0.4332. It is 0.6247. 0.6247. That is 62%. And but we want the count. Multiply this value with 1000. Now it is 624.7. That is approximately 625 students. 625 students have scored between 40 to 60. So, this is how we can interpret the probability values, and we can make use of normal distribution in order to model the data or predict the values based upon the historical data, and we can make decisions regarding how many, if we consider this situation, how many students scored 40, how many students scored between 40 to 60, and all these values we can find out chances, and as well as count also we can calculate it, like how we have done in this problem. This is how we can make use of normal distribution. Therefore, by the end of this lecture, we came to understand how to calculate normal probability, how to read the values from normal probability table, and also how we can obtain the normal probabilities for different cases like less than, more than, in between, how we have to calculate, and also how to interpret the value of normal probability. All these are the things which we have, concepts which we have understood by the end of this lecture. Thank you.